Hey, so if you're a Spring Boot developer, I've got something for you that I think is going to completely change how you look at your tests. We're talking about a tool called PITest and a really cool technique called mutation testing. Let's dive right in. All right, so here's our game plan. First, we're going to tackle the big idea, what it even means to test your tests. Then we'll get hands-on and set up PTest for the first time. After that, we'll learn how to actually read the PTest report, which is super important. Then we'll get into some real-world strategy, and finally, we'll wrap it all up with some quick tips and common questions. Sound good? Okay, let's kick things off with Chapter 1, Testing Your Tests. Before we even think about touching any code, we need to understand the why. Like, what problem are we actually trying to solve here? Well, it's all about making sure our tests are, well, as good as we think they are. So let me ask you something, and I'm pretty sure every developer has been here. Have you ever written a test, saw it pass, everything's green, you ship your code feeling great, and then, boom, a bug pops up in production that your tests completely missed? It's the worst feeling, right? So frustrating. Well, that exact problem is what mutation testing is here to solve. You can think of it as a way to, well, test your tests. The tool PTest is kind of like a little gremlin that sneaks into your code. It makes these tiny, almost invisible changes. We call them mutations. And then it runs your test again. The big question is, did your test notice? If a mutation slips by and your tests still pass, you've just found a hidden weakness. And when I say tiny changes, I mean really tiny. So let's look at a super simple example. You've got a basic if statement, right? If condition. What PITest does is it creates a version of your code where that condition is just hard-coded to true. Then it makes another version where it's hard-coded to false. Now, if your test suite passes in both of those scenarios, that's a huge red flag. It probably means you're not really testing both sides of that if statement at all. And it's not just about simple true or false stuff. Think about a method that returns a list. Your test probably checks if it returns a list with stuff in it, right? But what if PITest jumps in and changes your code to return null instead? Or what if it returns an empty list? If your test still passes after those changes, it means your test isn't as thorough as you thought it was. It's missing those critical edge cases.
So let's be super clear on this term. In the world of mutation testing, a mutant isn't some comic book character. It's simply a temporary version of your code that has one of these small artificial changes introduced. And our job, or rather our test's job, is to find and kill every single one of them.
All right, Chapter 2. Now that we've got the what and why down, it's time to get our hands dirty. Let's walk through how to actually set this up. And trust me, it's a lot easier than you might think. Okay, first things first, what do you need? For this walkthrough, we're going to be using IntelliJ, and a key requirement here is you'll need JDK version 11. And, it goes without saying you should have a basic handle on Spring Boot, Java, and Gradle. That's pretty much it. So go ahead and open up your build.gradle file. The whole thing kicks off by adding just one plugin. It's info.solidsoft.pytest. This is what gives PITest its power. It hooks right into Gradle's process and lets it mess with your code right before the test run. You just pop it into your plugins block just like you would with any other. Now, here's a massive pro tip, and you're going to thank me for this one. Running mutation tests on a whole project can take a while. So to save yourself a ton of time, you can add a PITest configuration block. In there, you can tell it exactly which code to look at using target classes and target tests. This is a game changer. You can focus just on the one thing you're working on and get feedback in seconds instead of minutes. And now for the moment of truth. Let's get into Chapter 3, reading the PITest report. We've set it up, we've run it, and now we get to see what it found. This is where you find all the good stuff. So once you run .gradle-w-test from your command line, the tool does its thing and spits out this really nice, clean HTML report. Honestly, you should think of this as your new dashboard for test quality. It gives you a great overview and then lets you click in and see the details for every single class. Okay, let's zoom in on the report for our example employee service. The first thing to look at is anything highlighted in green. This means a mutant was killed, and that's a good thing. It means PTest changed something in the code on, say, line 18, and our test was smart enough to catch it and fail. That's a win. It's exactly what we want to see. Now, this next one is really what we're looking for. See this line highlighted in pink? This is a mutant that's survived. This is bad. It means PITest changed the code, but our test didn't even notice. It just kept on passing. This is basically a big flashing sign telling you that your test for line 22 is weak and has a blind spot.
And finally, you've got the lines in bright red. This status is no coverage, and it's the easiest one to understand. It just means that not a single one of your tests ever even ran this line of code. So yeah, we have absolutely no idea if it works. So there you have it. Green is good, pink is bad, and red is, well, it's missing entirely. All right, let's move on to chapter 4. We know the theory, we know how to read the report, but how do you actually use this in the real world? On a real project with deadlines and a whole team, without bringing everything to a screeching halt. I think the absolute most important piece of advice is this. Think of mutation testing as a coach, not a gatekeeper, especially when you're just starting out. Don't set it up to fail people's builds or block their pull requests. Use it as a teaching tool, something that helps everyone on the team see where their tests could be stronger. And please, whatever you do, do not aim for a 100% score right out of the gate. I promise you, that's just a recipe for frustration. A much better way is to take it step by step. Start with a realistic goal, something like 70 or 80% mutation coverage, and only apply it to your most important critical code. As the team gets more comfortable with it, then you can start raising that number over time. This is all about being smart with your time and resources. You absolutely want to run mutation tests on your core domain logic, your service layers, your important business rules. That's where the value is. But you should totally ignore the simple stuff. Don't waste time on DTOs, basic getters and setters, or config classes. Focusing on what matters keeps the whole process fast and makes sure the results are actually useful. And here we are, the home stretch. For our last chapter, let's just quickly run through some common questions and nail down the biggest takeaway from all of this. Okay, some quickfire FAQs. First, does this work with Maven? Yes, it does. There's a PITest Maven plugin you can use. What JDK version do I need? For the setup we just walked through, you'll need JDK 11. And can I run it on just one file? Yes, you absolutely can, and you should. That's what target classes and target tests are for, and it makes your life way easier. So look, if you only remember one thing from our chat today, let it be this. Mutation testing isn't really about checking your code. It's about making you a better developer. It literally forces you to think about all those tricky edge cases, the nulls, the empty lists, the off-by-one errors. It trains you to write better tests, and in the end, that just makes you a stronger, more thoughtful engineer. For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.